In this video, we will discuss on how to do the analysis on the synchronous counter circuit. So you are given a counter circuit. Based on the counter circuit, you need to do the analysis part. Okay. This circuit is a synchronous counter circuit. How to determine that this is a synchronous counter? So you can look at the clock pulse. So all the JK flip-flop has the similar clock pulse. So that means this one is the synchronous counter circuit. So based on this diagram, based on this counter circuit, you need to identify the J and K expression. Okay, determine the J and K expression first. In this circuit, you have 3 JK flip-flop. So that means you have JA, JKA, JKB, and JKC. So total of expression is equal to 6. So you need to identify what is JA, what is KA, what is JB, KB, JC, and KC. So how to identify? Look at this J and K. So this one for JA and KA. So JA and KA come from the same source. So this source is AND gate, and AND gate come from B and C. So B and C go through the AND gate and become the input for JA and KA. So that's mean JA and KA equal to B times C or BC. Okay, next look at the JB and KB. So JB and KB here come from come from C. Okay, C. So JB equal to C, KB equal to C. Next, look at JC and KC. So JC and KC here come from 1. So KC equal to 1, JC equal to 1. Now you already have the expression for JA, KA, JB, KB, JC, and KC. So based on this expression, you need to derive the excitation table. So your excitation table must have present state, must have the next state, and must have the value of JK. So based on this example, okay, you have JKA, JKB, JKC. That means you have 3 JK flip-flop. So you must have A, B, and C at the present state. And then you must have the A prime, B prime, and C prime at the next state. And then you have JA, KA, JB, KB, JC, and KC at the JK column. So now, after you construct your excitation table, you need to fill in your excitation table. Okay, this one we have 3 JK flip-flop. So that means you have A, B, and C. So the possibility is 8. 2 power of 3 equal to 8. So your number must start from 0 until 7. So at present state here, decimal part. At here, this part is the binary. So 0 becomes 0, 0, 0. 7 become 1, 1, 1. Okay, next part, you already know the expression. JA and KA come from BC. So look at the BC. BC 0, 0 equal to 0, 0, 1 equal to 0, 1, 0 equal to 0, 1, 1 equal to 1. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. So you fill up JA and KA. Okay, next, JB and KB equal to C. Look at this C, 0, 1, 0, 1, 0, 1, 0, 1. So fill up JB and KB. Okay, next one, JC and KC equal to 1. So you just put 1 for every rows. Okay, then after this part, you need to identify what is the next state, because you need to draw the transition diagram at the end of this analysis part. So how to identify the next state is based on the value at the JA, KA, JB, KB, JC, and KC. Okay, for example, this one, JA and KA equal to 0, 0. Okay, 0, 0 means whole. So look at A equal to 0, so A prime equal to 0. mean we hold the value, the previous value. The next state hold the previous value. Okay, JB and KB also equal to 0, 0. So that's mean B 0, the next B is 0. Next we have JC and KC. JC and KC equal to 1. So 1 means toggle. So the present state is 0. So the next state is 1. Okay, now you already know the first row of the next state value. So you have number 1. So that's mean your state from state 0 will goes to state 1. Okay, next you need to identify the second row. JA and KA equal to 0. So that's mean hold the previous value. So the present state is 0. This one will be 0. This one is 1, 1. Present state is 0. So this one will be 1. This one is 1, 1. Toggle. So 1, 0. So this is your value for the next state. So based on this row that you know that from state 1 it will goes to state 2. Next you need to identify the third row. JA and KA 0, 0, that's meaning you hold the previous value. This one is 0, this one will be 0. Okay, 0, 0. So this one is 1, this one will be 1. 1, 1, toggle. So this one is 0. The next C prime must be 1. Okay, so the next state is number 3, state number 3. So from state 2 it will goes to state number 3. Then you identify the next value based on JA and KA. 1, 1, so that's mean toggle from 0 to 1. 1, 1 here, toggle from 1 to 0. And then this one also toggle 1, 1 to 0. So you get number 4, 1, 0, 0. Okay, then identify the next state for the next row. Okay, from here you have 0, 0. So hold the value 1. Hold, become 1. 0, 0, hold the value. The value is 0. So hold the value 0. This one 1, 1, toggle. This one is 0. So this one become 1. So now you get number 5. Okay, 1, 0, 1 equal to 5. So identify the next state. Okay, JA and KA we have 0, 0. So the previous one is 1. So hold the value 1. This one is toggle. 0 become 1. This one is toggle. 1 become 0. So you will get number 6. Okay, the next part. 0, 0. Hold the value. 1 become 1. Hold the value. 1 become 1. Toggle. 0 become 1. So you will get 1, 1, 1. And then the last row, you have 1, 1 at JA and KA. So hold the value 1. At here 1. At here, 1, 1, toggle the value. This one is 0. Okay, this one is 0. This one is 0. So at last you get 0, 0, 0. So the number is 0. So now you already complete your excitation table. So based on your excitation table, you need to draw the transition diagram. So based on this present state and next state, state 0 will goes to state 1. State 1 will goes to state 2. State 2 goes to state 3. State 3 goes to state 4. State 4 goes to state 5. 5 to 6. 6 to 7. 7 goes to 0 again. So this is your final transition diagram. Okay. 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and then after that 7 goes back to 0. So this is your final state transition diagram for the given synchronous counter.